SwayamPrabha. Digital India. Educated India.
Good morning, friends. As you are aware that in the last class we talked about product design. This is a course on production and operations management where we are talking about unit number 2, that is design of products, services and selection of processes. In our previous class on this subject, on this chapter, we talked about the salient features of product design, and then we were studying the various methodologies of product design. In that series, in the previous lecture, we covered quality function deployment. Today, continuing from that, we will study some more approaches towards quality design, towards product design. Second technique which we are going to study for product design is Taguchi design, Taguchi methods of design. The Taguchi, he is a quality guru from Japan. His contribution towards product design are threefold. First, he gave the concept of consistency and value loss function. Second, he developed the concept of design of experiments. And third, he gave the concept of robust design. And we will see these three concepts one by one. Look at this figure. There are two, let's say, some agency want to hire two gunmen, to hire a gunman. They are having two persons who have reported for the skill test, and the results of their skill test are reproduced here. Gunman A is able to shoot 2 shots at the bullseye. Others are scattered on the frame. Whereas gunman B is not able to shoot even a single shot at the right place, but all his shots are concentrated at one place only. So the question is, which gunman you are going to select for the job? Obviously, many of us will say that, okay, we will select A because at least 2 of his shots have hit the bullseye. But my answer is B, because A is a unskilled worker. He doesn't know what he is doing, and incidentally 2 of his shots have hit the bullseye. Whereas in case of B, he is highly consistent, though none of his shot is able to hit the bullseye. So idea is, if there may be one single reason because of which all his shots are not falling at the right place. If we remove that cause, it may be some error in his gun. If we remove that cause, all his shots are going to fall here at the bullseye. So he is a skilled person, but there may be some fault in his process. If that fault is removed, all his shots will fall at the right place. So what we are trying to say through this example is, in the product design and in the process selection, our major aim should be the consistency of products, because when products are going to the customer, he is expecting the same quality, same feature, same color shade, everything same, and that is what the value of brand is, so that he need not to inspect every time when he is purchasing. He trusts the product, he trusts the brand and purchase it, and that trust is created with the help of consistency. So one of the important aspects given by Taguchi is consistency of products. We should design the products which can be produced consistently with the uniformity. All the products are produced of the same quality. So that is one concept which is given by Taguchi. Coming to the second aspect, that is quality loss function. He further specifies that we give, in the design stage, we give the specifications, but specifications are only to take care of our constraints of the production. The performance of the product will be the best when it is produced at the target value. Suppose this is the target value at which you want to set, let's say, diameter of some engine component. The requirement is, let's say, 20 mm. The product will perform if it is produced at 20 mm. You may give tolerance of plus minus, let's say, 100 microns, and that is your specification limit. But as you deviate from the target value, the loss to the society start increasing. This loss to the society is in the form of maybe more energy consumed, the mileage of the engine may reduce, or it can heat up and generate more fumes, or the life of the engine is reduced, or it can be in any other format, or it may require more rejections, it may lead to more rejections in the testing stage. So all these are together called the loss to the society, loss during production, loss during operations, or loss due to the product to the environment. So these are some of the losses to the society which are there. As you proceed, as you move away from the target value, the cost increases on the both the side, on the plus side as well on the minus side, even though you are within the specification limit. So that is a very beautiful concept. So we have to see that, and that is why you will find that earlier our cars, etc., automobiles, if we take a specific example, the fuel efficiency of the car used to be only 10 kilometer per liter, 12 kilometer per liter. But now we are having with the much bigger engine giving a fuel average of 20 kilometer per liter. Why? How this is happened? This is happened all due to the precision in the manufactured components and obviously reduction in the weight of the vehicles also. So with the help of good machinery, good manufacturing processes, we are able to, earlier the tolerances used to be in millimeter, which has now become in microns. And further it may happen that we are having further 20 micron, 50 micron kind of a tolerances. So as we move towards the target value, the performance of the product improves, the loss to the society decreases. This is second example conveying the similar kind of a thing. Both manufacturer A and B are producing within the tolerance limit, but B is producing a uniform kind of a distribution where all types of products are produced from left corner to the right corner. Whereas in case of A, most of his products are falling very near to the target value. If we say this is the target value, most of his products are falling close to the target value, few are going away from the target value. So the quality of products of A will be much better as compared to quality of product manufactured by manufacturer B. This we have witnessed in 1990s, etc., when cameras were coming, same model, same design, same color, same feature, everything. It may be made in Japan, it may be made in Korea, it may be made in India. And we found that the performance of the cameras manufactured in Japan were having higher premium also, and performance is also better, though it is same model. It is all due to the difference in the manufacturing, how far your products are close to the target value. If product is close to the target value, performance of the product would be much better as compared to if it is within the tolerance limit only. So this is the second concept which is given by Taguchi, which is called quality loss function. Now coming to the next part of his understanding, that is optimization of process, products and processes. He gave the concept of robust design, signal to noise ratio. He said that we have to take the design and three stages. One is the system design, second is the parameter design, and third is the tolerance design. The design process should proceed in three steps. First is the system design. The engineers apply scientific and engineering knowledge to produce a basic functional prototype design. It also includes the selection of materials, components, tentative product parameters, values. So here at a system design, you are broadly thinking, okay, this is going to be the size, dimensions, materials, features which I am going to have. At the second stage, you are designing the parameters. Here the optimization will come. Taguchi design of optimization will come here. Here we are optimizing the setting of process parameters so that my product is having a good performance and robust in nature. We will talk robust in the next slide. And third is the tolerance design. So we optimize the tolerances also. The purpose of the tolerances is it should not be too tight. If it is too tight, that may be difficult to manufacture. Your manufacturing processes may not be able to support those tight tolerances and leading to high rejection and high cost of manufacturing. On the other hand, if the tolerances are too loose, in that case, we will find that the performance of the product is not up to the mark. The product performs poorly in the market because high tolerances means you are away from the target value. So in that way, we have to optimally design the tolerances also at a third stage. So this is a three-step approach which is suggested. Then the Taguchi method uses special design of orthogonal array. This is the fourth approach which is given toward design of experiment. How to optimize the parameters, how to optimize the parameter design of experiment. With minimum number of experiments, how can we achieve the optimal optimal combination of the parameters? So in this case, he suggested the orthogonal array, which is based on the statistical thinking, and to study the entire parameter space with a small number of experiments. Key point is small number of experiments. Like if you are having 3 variables, 3 parameters, and each is having 3 levels, we need to conduct 3 raised to the power 3, that is 27 experiments if we are using the full factorial design. But with the help of Taguchi orthogonal array, even if we use O16 or O9, we can get the same optimal results with 9 experiments or 16 experiments as we would have got by conducting 27 experiments. So with small number of experiments, we were in a position to reach to the optimal combination of parameters. The experiment results are then transferred into a signal to noise ratio also. We can find out how much is the disturbance, how much is the noise in the given system. That will lead to the robust design. If less the noise, more the signal, better is the performance. Noise is nothing but a variability. Noise is nothing but variability in the performance. And signal is the mean value of performance. Mean value of performance. So if my mean value of the performance is high and my noise is less, variability is less, that is the best way of having the product, best way of designing the product. Now coming to the third aspect. So first technique we have studied quality function deployment. Second we have studied Taguchi concepts related to product design. And now at a number 3 we are talking about concurrent engineering. So concurrent engineering can be defined, though I told you in the introduction to when we are talking about various techniques, introduction to that, I gave you some idea about concurrent engineering or simultaneous engineering. So concurrent engineering can be defined as the simultaneous development of project design functions with open and interactive communication existing among all team members for the purpose of reducing time to market, decreasing cost, and improving quality and reliability. So the keywords in this is simultaneous development. And then communication, interactive communication with all the stakeholders. Stakeholders are marketing people, product development people, research and development team, manufacturing team, procurement team, costing and finance team. So these are all various departments which are associated with the design decision. So all the decisions are, if are taken together simultaneously, obviously the total cycle time to reduce to produce the product will reduce. So that reducing time to market, the moment you said that there is a need for a new product and the time you are able to bring it to the market, that time can be substantially reduced if we are following the approach of concurrent engineering, deciding about all the parameters, all the aspects which are required in the launch of the product, in the product management at the same time. And obviously, because of there is no iterations or no improvements or no backtracking of the design process, the total cost of developing the product will also decrease drastically. And it will improve the quality and reliability of the design also, because these factors are taken into consideration right in the beginning of the idea generation stage itself. So the team provides a primary integration mechanism in concurrent engineering program. So integration, it integrates the ideas and thoughts and requirements of all the stakeholders. There may be ideas, they are having different ideas about the product, different expectations from the product design. So they are taken care in the beginning itself. There are 3 types of teams. One is the program management team. Their idea is to coordinate with all the stakeholders and end to end, right from the idea to the launch and the further improvement, etc. Everything is a responsibility of program management team. They will look after the forming of the team. They are the real owners of the. So there are three types of teams involved in product development in the concurrent engineering approach of product development. First team is called program management team. Their role is end to end, right from the idea stage till the product is launched in the market successfully. So they will be responsible for forming the teams and then also developing other documents like customer support documents, warranty clauses, and training to the marketing team, giving instruction to the marketing team, and all other aspects of this. They are the people who will look after the total management aspects of the program. Second team which is there is that is a technical team. The technical team role is to design, to specify the functions of the product, to specify the various other requirements of the product, more from the technical aspects point of view, how the product is going to perform, what are the features required, what are the dimensions required or specifications required of the product. Third is that design build team. They will also look after this team along with considering the technical aspects given by the technical team. They will put the aesthetic aspects, form aspect, marketing aspects of the product into the product. So they are giving the final shape to the product. So they are the design build team, and they will also be responsible for manufacturing of this product so that it meets the customer requirement and it is as per the design given by the technical team and also the requirements given by the marketing people. So like this, so three types of teams work together in this design process. There is a time saving of concurrent engineering programs are created by performing the activities in parallel. This I am saying simultaneously, parallel activities are performed. So that helps in saving the time and the cost. Now coming to design for manufacturing. Martinici is the name of the author, the book from which I have taken these principles. You can read more in the book about that. So, if from the manufacturing point of view, we look at the design, the first and foremost principle in this case is minimize the number of parts used. Minimum the number of parts in the product, more will be the easy to manufacture. You have to manufacture less number of parts, so it is easy for the manufacturing. Second is, as far as possible, use the common parts. Like in a product, let's say in an automobile, in a scooter, in a bike, or in a car, or maybe in a television, or maybe any product, there may be some kind of fasteners are required. If you specify different type of fasteners at different places, it will become difficult for the manufacturing people to manufacture them or procure them. On the other hand, if we somehow are able to reduce the variety of the fasteners or components required, then it is very easy for the manufacturing people to manufacture. Many times you have seen that the products left side and right side of the component, though they are mirror image, but they are two different components. If we design in such a manner that the same component can be used either on the left side or on the right side, then it is very easy. Similarly, in a domestic activity, we find that there are certain products which are manufactured in such a manner that the components of similar nature, they assemble together in a way and form the final product, lunch boxes, etc. The top and bottom are of same size, same thing, and design in such a manner you assemble them and you can get a final product. So at the place of fasteners and other components and parts, you can design in such a manner that you can reduce the variety of the components used in manufacturing of the part. So that is a big help for the manufacturing. If we are able to produce the common components, reduce the variety of the components. In our introduction lecture, we said that as the variety increases, if the variety is doubled, the cost per unit increases by 20%. The cost per unit increases by 20%. Thumb rule, in 20%, it may be 25%, it may be 15%, but a rough idea, the cost per unit increases as the variety increases. So on the other hand, if we are able to reduce the variety to half, the cost per unit will reduce by 20%. Third important thing is use the standard components as far as possible. The components can be standard or it can be special. Special components means which has been need to be manufactured for that particular product only. It is not used other places. Whereas standard components which are manufactured in bulk quantities as a commodity and required by several other products, several other manufacturers also. So if we are specifying the standard components which are available off the shelf, which are available, you need not to develop a vendor for that, then it will help in better in reducing the manufacturing effort, in reducing the procurement effort. So always try to prescribe the standard components wherever it is possible, rather than the special components. Fourth important principle of design for manufacturing is simplify the assembly process. You should design the process in such a manner that the components are getting press fit of its own without much efforts in orientation and in bringing them together. You bring them together and it is taking its place very smoothly without much effort. We have seen in toys, etc. There are certain toys you just even a small child of 3-4 years is able to bring them together and assemble it. On the other hand, there are certain toys if it get opened, it is very difficult to fix them back because of design itself. So we should design the components and parts in such a manner that it is easy to assemble. There should not be much problems in the orientation of the components, etc. It's taking its place much easy. So that is the fourth principle which we have to follow in the design with respect to manufacturing. Fifth important principle for a designer to be kept in mind to help the manufacturing people is use modularity to obtain the product variety. Modularity is very important concept these days. All such varieties, different type of core models which we are seeing, you will find that there are certain models which are produced and these models are assembled together in different manners to produce the variety. Similarly, if you look at the computers and laptops also, it may have few modules in the form of RAM, in the form of hard disk, in the form of motherboard and so on, and these can be combined in different combinations to produce the variety. You can produce a low-end computer laptop also, or you can produce a high-end computer also by combining these modules in different manners. So that is the concept of modularity to obtain the product variety. These days we are finding that many products are manufactured in modular manner, and you give your specifications and accordingly these modules are assembled together and then the final product is produced. Maybe the concept of this modularity has come from our roadside dhabas and restaurants also. If you go to the roadside dhaba and stop there and you ask the attendant waiter there what is in the menu, in one single stream he will give you the list of 40-50 items. And if you go to the kitchen, you will find none of these items is available in the kitchen. Only he is having a few gravies, boiled peas, paneer or boiled aloo, and all such ingredients are there. So depending upon your requirement, he will assemble, he will give the final shape to the vegetable which you have ordered. So he keep the ingredients ready. These ingredients are nothing but the modules. It keeps the modules ready and then the final product is assembled by combining these modules together. So the same analogy is being used in our manufacturing products where several models can be created by combining the different modules in particular manner. And that also leads to design this make to order also. Like a Dell laptop is a very important example, make to order. You can order the laptop of your specification and within 10 days you will get the delivery of that exactly as per the specification which you have prescribed. So that is the kind of thing, then that all is possible because design is such that which is modular in nature. You combine the various modules and produce the product. This is also the modularity concept is also important. The product is manufactured in one country and then it is sold in several other countries, and different countries may have a different power requirement. maybe certain, like in India we are having 220 volts, some other countries are having 110 volts, and then the language written on the printers, computers and those products, user manual, etc. So if we are creating in a module manner, then they can be assembled at the final stage according to the country of dispatch, and it can be very efficiently fulfill the requirements of different countries. So that is the concept of modularity in the product design, to create the variety in terms of specifications, variety in terms of fulfilling the needs of different countries. The another principle which we want to discuss here is make product specification and tolerances reasonable. I said in Taguchi also, our tolerances and specification should not be too tight, should not be too loose also. Similarly, specification should not be too rich or it should not be very poor. Both are having their cost implication and performance implication. And cost implication and performance implication will obviously have a impact on the saleability and the performance of the product in the market. So from that perspective, we should produce the specification which meets the customer requirement and which we are able to produce at a cost which the customer is ready to bear. If we keep too rich a specification and that lead to increase in the cost of the product, and we may not find the target market which is ready to purchase those products at that high price. So we have to keep a balance of specification with target market and the purchasing capacity of that target market. And tolerances, it should not be too loose or too tight. If it is too loose, it will affect the performance of the product. If it is too tight, it will affect the cost of manufacturing. There may be more rejections, or there may be, you need to have high precision technology which is expensive in nature to produce those high tolerance products. The most important aspect, as given by Taguchi also, robustness. Our product should be robust. Robustness means my product should be able to perform in different external environment, different external conditions. Even a 4-year boys can also play with that, and a senior person can also play with that. It will give the same performance. You use the product at a low temperature places as well as at high temperature places also with the same level of performance. Even the road conditions are not very good, your car should give the same kind of a performance. So that is the feature of robustness. It is robust, it can work very well with the same efficiency, with the same effectiveness in different operating conditions. So that is the concept of robustness. So this is all, these are some of the principles I have discussed here related to design for manufacturing. There may be many more also. We are not saying that these are the only things which we have to consider. There may be many more such kind of things which we have to keep in mind. This is just to trigger your thought process that at the design stage, we should keep in mind the manufacturing aspects of product design. Then come the design for assembly also, in continuation to design for manufacturing. It should be easy to use fastener. The fastener should be such that they are easy to assemble. It should not be too. Another important aspect, when I was talking about the common components also, you need that tools to tighten or loosen the fasteners or such. If you are having a variety of such kind of fasteners or components, obviously you need to have that much variety of the tools also for the purpose of assembly and for the purpose of disassembly also. So if you use the standard component, use the common component and the standard component, the tools available in the market can be used and less number of tools are required for assembly and disassembly of the products. Attention to orientation and accessibility during assembly should be kept in mind. How this part are going to be accessible from the outside. Many times in automobile we have seen that there may be a small fault, but that component or that location of that is very deep inside the engine. You have to take out several components and then you reach to that particular part. And the failure or the problems or the maintenance requirement of that particular aspect is very high. So we should keep in mind that such kind of parts, components, etc. should be little accessible from the outside itself, so that they can be maintained, they can be, in case required, assembled, disassembled, can be done very easily. Attention to the testing also, certain parts which need testing after assembly, that should be also kept in mind while designing the products. And foolproof operation and assembly. Obviously, our design should be such, and after assembly, we need not to do too many testings or adjustments in the product. It should give a foolproof operation without making any uh, um, poor quality. The concept given by Japanese is called pokayoke for foolproofing. That means your process should be such that it will not make a mistake. Even a fool can operate the machine without making a mistake. So that kind of product design, if we are having, that it will be produced of right quality without making a mistake. Uh, so that kind of aspect, if we keep in mind while um, designing the product, will go a long way in improving the quality of the product. In this aspect, we can say that the operation will not be completed unless all the parts are there for the assembly, or you won't be able to proceed to the next workstation unless each and every part of the previous station is done accurately with the right torque, with the right components, and with the right orientation. If that is not done, it will not move forward, or the product cannot be assembled in a wrong orientation. Just like the chip which we are using, SIM we are using in the mobile, it has been designed in such a manner, it gives a pokayoke. You cannot insert the SIM into the mobile in any other manner other than the right manner. So that is the kind of a foolproofing, design foolproofing of the product, that you cannot insert the component in a wrong manner. It will not allow you, it will not permit you. So that is the concept of pokayoke. In manufacturing, in processes, it is used at several places, the concept of pokayoke. Like another example I can give here, foolproof operation and assembly, just like filling air in tubes in our vehicles, filling air to maintain the pressure. Earlier we used to have two nozzles, one nozzle to fill the air and second nozzle to check the pressure. But now the new instrument, new gadgets which are coming, new products which are coming, they are having both the functions inbuilt together. So there is only one nozzle, and you set the pressure. Let's say in a car you need a pressure of 34. So you set the pressure at 34, insert the nozzle, and it will stop automatically when the desired pressure is achieved. So there is no question of making a mistake. So that is called foolproofing system. So design the product in such a manner that it is foolproof, no chance of making a mistake, and so that the quality is ensured. So these are some of the ideas which we have to keep in mind while designing the process, and these ideas will help in improving the quality. These ideas will help in reducing the cost of manufacturing, cost of assembly, cost of maintenance also. Maintenance is nothing but disassembly of the components and then assemble them back. So all these aspects will help in performance of the product in the hands of the customer. We also be design stage, we should be also sensitive to the environment also. So environmentally sensitive design is another important, like we're talking about green products, green processes, so that they are not harming the environment. Harming the environment can happen at three stages. One, when you are manufacturing the product, you may be drawing the raw materials which are harmful or which may affect the environment badly. While operating the product, you may be, while operating, it may lead to adverse impact on the environment, like CO emission in our vehicles, which affect the greenhouse effect and affect the ozone layer and other global warming. And then when you're disposing the product, at the time of disposal also, it should be environmental friendly. So we should keep in mind when we are designing the product that at the manufacturing stage, it should be green manufacturing, logistics also green, and then operations also, operating of the machine, operating of the product gadget should be green, and then disposal of the product should also be environmental friendly. So in that connection, 3-4 bullets here. Reduce the amount of material used. While manufacturing the product, see that if it can be manufactured with less of the inputs, whether it's a steel, whether it's a coal, whether it's energy, whether it's any other kind of a natural resource which is required, try to see that as minimum as possible should be reduced, especially the energy aspects. In steel manufacturing and in other industries, we are finding that now people are talking about the products and processes which are consume less energy. Second is substitute for harmful materials also. Don't use harmful materials in your product design, like plastics, different types of plastic which are very harmful. Disposal is very, very difficult, and it affects our ecosystem also. As far as possible, use the recycled material. Uh, if you are using the recycled material, there are several products where it is written, especially in the packing materials, etc. We find that recycled product. So that saves our environment. We need not to draw more materials from our natural resources, whether it's a tree, whether it's from the mining or in some other manner. We should not be drawing too much material from the nature. Make products durable and recyclable. Our design should be such that they are having a long life, so that less material is required, less they work for the for a longer period, and they are recyclable. Once their life is over, it can be end of use or end of life, it can be recycled and again it can be made workable. In that context, remanufacturing is very important technique which is employed especially for large equipments just like earth movers, etc. In the earth mover, etc., we are finding that the material, the frames, etc., which are used, they never wear and tear because they are non-moving parts. Whereas electronic components and other movable components, they get wear. They are having a life of 5 years, 10 years, 20 years, different components. So if we use the concept of remanufacturing after the life is over of these components, we replace only those components which are small in number, small in size, whereas the frame, etc., we can use as it is. So that saves a lot of we need to use less of the material from the nature in the form of cast iron or other materials which are there that can be reused in the new product also. And remanufactured products are as good as the original products, because only electronics have deteriorated or some moving parts, engine parts, etc., have deteriorated, where the main frame, the total structure of the product remain as it is without any damage to it. At the end, when we have done the all the aspects, what is the output of the design processes? It can be production documents in the form of design specifications and design, or bill of material. Bill of material tell you what are the various components and parts required to manufacture a product. It is like this. This is suppose your final product A. To manufacture a final product A, you need 3 types of sub-assembly. Sub-assembly B, sub-assembly C, sub-assembly D, and you need 2 units of sub-assembly C. And further, to manufacture B, you require components E and F. You require 2 components of E and 3 components of F. Similarly, to manufacture C, you require F and G, 2 components of F and 1 component of G. To manufacture D, you require some components like this. So this type of diagram reflects the bill of material. So from the face of it, from this document itself, you get to know what all is required to produce the final product A. And then the process requirements also, it should tell that these are the processes, whether you should use the ordinary lathe, general purpose lathe, or you use the CNC machines or some other technology, what type of technology, and you can prescribe that also while designing the product, how this is going to be assembled, what types of jigs fixtures are required, what is the tooling requirements for that, what are the testing equipment requirements for that. So all these things can be specified at the time of in that production document. So production document nothing but which helps in producing of the given product design. You can also give in the form of prototype also, which is a physical or geographical representation of proposed product. So prototype helps in better understanding of the product by the manufacturing people, by the marketing people. So many times along with the product design specifications and production document, the prototype is also given. And these days we are having very good technologies available to produce the prototypes in a very fast manner. And these techniques are given alternate names, like we call it 3D printing, or it can be additive manufacturing. So even a one single component can be produced in a most economic manner, and this is also called rapid prototyping also. Nowadays these machines are available where earlier the material used was more plastic, but now in the metals can be used ferrous, non-ferrous metals can also be used in these machines to create the prototypes, and they can be as good as the final product. So many products which are required according to the customers, where the customization is very high, especially the various limbs etc. for physically challenged people, or the stents etc. which are used in heart surgery, medical components, various types of implants etc. For that you can create the prototypes, or you can manufacture the final component also with the help of these types of technologies. So that is the concept of product design. Now coming to the service design, the characteristics of services, they are intangible in nature and perishable product. If you are not using it, it will perish. Output cannot be stored, it has to be consumed immediately. There is a high customer contact. Customer is part and parcel of the design also. He is also part and parcel of while the transformation takes place. The response time is short. The time between the demand is created and demand to be fulfilled is small as compared to the manufacturing. In case of manufacturing, the customer is not in contact with you. You can take your own time in manufacturing the product and bringing it to the market. But in case of services like a restaurant, you enter to the restaurant and you want a quick service for that. Short response time is required. Similarly, for travels, hospitals, etc., all these service system, a short response time is required. Services are usually having a local market, and so they are whereas manufacturing is having more national and international markets, whereas services are having more local markets, and services require usually small facilities. They are not big size facilities, and generally labor intensive, and quality not easily measured. This point also kept to be mind when you are designing the service. That product you can define, this is my quality specification, whereas in case of services, the quality is obviously it is a feature of the service, but also it is how the customer perceives, what are the expectation of the customer. Same quality of service can be you may get a very high rating from one set of customers and maybe a very poor rating from the another set of customer, or for the same customer also, in one of the setting he may give you very high rating, in another case he may give you very low rating, depending on his expectations, what he expect at that time, what is his mood, and what is for what purpose he is going for that service. So depending upon that, just like in case of a restaurant, person has gone there to relax and to spend some time, and you start serving him very fast, he will get his response will not be very good, he will not be satisfied. On the other hand, if he is very hungry and you are taking more time in serving him, that also lead to a poor perception of the quality. So you have to keep in mind, this is where the customer understanding of the customer requirement comes very handy, which is not so critical in, it is also important for product design, but it is more critical for service design, service delivery, that you should understand the expectations of the customers also, and these expectations are highly dynamic, changing very fast. So most of the principles in designing the services are same as we have discussed in the design of products. We can apply quality function deployment, we can apply other approaches also, because here also we want consistent quality of services. We also want customer expectation, why, so the customer to be included in the design of the services. So all aspects are same, but along with that we have to keep in mind some additional features like high customer contact, short response time, and quality is not easy to measure while designing the services. So these are the additional aspects which we should keep in mind. And secondly, these days with the respect to services, we are observing smart prices, because the product is perishable and intangible, you cannot store it. So what you have to do, you have to see that your utilization of the, just like airline seats, the important requirement for airline seat is each and every seat should be filled, because empty seat is not going to be used in the next flight. So that way we have to see, we have to play with the pricing to influence the demand of the services. So that aspect also we can say in designing of the services, we should keep in mind how we should do the pricing, dynamic pricing, smart pricing, so that whole of my capacity is fully utilized, fully purchased by the consumers. So while designing, we have to see to what extent will the customer be involved in the process, how quickly will the service be provided, how standardized or customized, whether I should provide the standardized service or the customized services. Both are having its own pros and cons, cost of providing the services and how much variety I should keep, or I should keep only single type of a product. So you have to decide based on the target markets or cost and other implications, what variety of services. So these three decisions, standardization, customization, and how much variety I should keep, you have to keep in mind. If you are designing for a, let's say, football, outside the football stadium, some product you want to sell, you go for the standardized product. There is no time available to customize it. Or if you are having variety, more variety, it may lead to shortages and wastages. So on the other hand, if you are working in a premium place where customers are ready to wait, maybe you are going for a high variety or customization also. And then you have to decide what geographical area I am going to serve with my services. We can classify the services, labor intensity, high or low, just like ATM. ATM are having low labor intensity. On the other hand, if we go to the restaurant, they are having the high labor intensity. Customer contact, high or low, whether customer is part of the design and also part of the conversion, also transformation, or he is only involved in the conversion process, like that. Just like a barber or a hair salon, you will find here that he is part of the design also and he is part of the conversion process also. So we have to keep in mind. And then the interaction with the customer, just like we say that university teaching vis-a-vis coaching. Coaching is more personalized, whereas university teaching is more standardized. Customer contact in designing the curriculum in university teaching is less, whereas in coaching, what you want to study, what is to be taught is decided by the student. Then come the customization, as we said, whether you are giving a fixed product or you are giving a choice or you are giving some kind of a adaptation, like in pizza, etc. You can have the toppings, etc. Or in case of tea, coffee, you can have with sugar, without sugar kind of a things. So you can have customization. Another important thing which we have to keep in mind, whether the action is on people or on the things, just like at barber or saloons or spa, etc. Action is on people. So here the designing of the product should keep in mind the safety of the people also, whereas if it is on things, the parameter may be little relaxed in that case. So we can classify the services in two categories, where the one is customer contact, where the customer involvement in designing the services like building the new house, creating the services like hairstyling. High contact, if it is a high contact, then you need more flexibility and then it is going to be less productive. On the other hand, the second important dimension is labor intensiveness. High labor intensiveness, just like in teaching, nursing, etc. There you need to have more number of employees, employee scheduling, training is important aspect. And if it is a labor intensiveness is low, just like in ATM, more technology intensive. So there we have to see how much capital investments are required. Customer contacts, this is one template which gives you some idea. Capital intensive versus customer contact. This set is which is having a very high capital intensive and customer contact is low, just like postal services, check processing, automated warehousing. And whereas charter travel, medical treatment, they are also capital intensive. Medical treatment, more equipment, machines are there, but high customer contact is there. Then come the labor intensive. Teaching, cafeteria are more labor intensive and high customer but less customer contact. And in the designing, customer contact can come at two places, one in designing, second in transformation. And then medical diagnosis, tutoring, they are having a more customer contact in designing the services. So here we need rigid process technology, here we need flexible process technology. Where customer contact is high, we need flexible process technology. Now coming to the third aspect, after talking about product design, then talking about the service design. Now how to convert these designs into actual products or services? You need some processes. So the selection of the process is the third important dimension in our this at this stage when we are talking about designing of the products. Along with that, we have to see what type of processes we should employ to convert the design into the physical products and services. First and foremost decision which you have to take, depending upon the volume and variety, we have to decide whether I should go for a mass production system or a batch production system or a job shop production system. We have seen earlier that if the variety is less and volumes are high, if I have to produce like a standard product, not much variety, then I can go for a mass production system. It can be true even for the services also. If you are providing only one type of a product, one type of a service, then it can be mass produced. Second is we have earlier said this is a mass production, then there is a batch production, moderate variety and moderate volumes, and then there is a job shop production system when the variety is very large and volumes are very. So depending on the volume and variety, I have to decide. Second important thing which we have to keep in mind at 3 stages, whether I should go for a special purpose equipment or I should go for a general purpose equipment or flexible equipment. So again, depending upon how much variety you have to produce, if the variety is very less, you can go for a special purpose equipment without much flexibility, meant for only one type of a product. If you have to create a variety, go for a flexible manufacturing system, like that. Third dimension which will be influenced by the volume, manual, automated or semi-automated. We have seen at our home applications also, if a small task is required, we are very happy in doing, like washing of a one handkerchief, rumal or something, you do it manually only. On the other hand, if 20-30 clothes need to be washed, I prefer automated washing machine. Or if some less quantity is there, you may even happy with the semi-automated. So it will depend upon the how much quantity I have to handle. So based on that, so manual, if the quantity is less, because what will happen, it's a play of break-even analysis. The technique is break-even analysis. How much quantity we have to produce. What happens in break-even analysis? We are having two types of cost. One is called fixed cost, another is called variable cost. In case of manual technology, the fixed cost is negligible, nil, but the variable cost is high. In case of semi-automated, there is some fixed cost. Let me change the color. In case of automated, there is some fixed cost, but the variable cost is less. In case of fully automated, we are finding that the fixed cost is high, but the variable cost is even less. So we are getting 3 points here. If the quantity is lesser than Q1, I should go for the manual process. If the quantity is between Q1 and Q2, I should go for semi-automatic. If the quantity is between Q2 and Q3, I can go for a fully automated processes. Same is true in the manufacturing, etc. also. As the volumes increases, we prefer to go for a automated equipment. On the other hand, for job shop kind of a system where the volumes are very small, we should prefer manual technology, general purpose machines. Then we have to take another decision. This is also called make buy decision, or insourcing and outsourcing, or make or buy decision. I am manufacturing a product. How much I should do inside my factory and how much I should take help from outside, how much I should outsource. So that is very important decision. Many a times, to begin with, we are doing only the assembly. We purchase all the components from the market, etc. and then we are doing only the assembly operation. Just like our car, Maruti car, when it was launched in 1985, I believe, most of the component parts were coming from the Japan, and we were doing only the assembly of that. And later on we start the indigenization process. We started manufacturing the components within the factory also, and then we are also looking at the outsourcing also by developing the vendors, etc. So that is the kind of thing we have to keep in mind, that how much I should do in sourcing within my own factory and how much I should outsource from outside. If the technology is changing very fast or requirements are changing very fast, then it is preferred to go for outsourcing, because outsourcing provides you the flexibility. On the other hand, before 1990s, the concept was more towards going for vertical integration, doing more and more things in house, because that saves the efforts on coordination and other things. But once this variety started increasing, technology started moving fast because of the globalization, because of the development in computer science, electronics, etc. Now we are more talking about outsourcing and horizontal integration. There is hardly any company now which is doing all end-to-end activities. Horizontal integration. So vertical integration, when you are doing all the things in-house. Horizontal integration, when you are more preferring the outsourcing. So that way we can we have to decide how much I still remember in 1980s we used to say that India's technology is only screwdriver technology. That means all components and parts we purchase from abroad, from other countries, and with the help of screwdriver, whether it's televisions, radios, or other electronics items, we were only doing the assembly process and then selling into the market. So, but now when we are talking today, most of the things we have started manufacturing indigenously in-house. So we have to see that what we have to do depending upon our capacity, competency, financial requirements, etc. We have to decide how much to make and how much to buy. We will discuss further this also. Further, 2-3 more points which we can take from this slide. That is economy of scope. What variety? What should my equipment? There are two things. One is called economy of scope. Another is economy of scale. Economy of scale and economy of scope. Economy of scale will tell you that if you are producing in large quantities, the cost per unit decreases. Economy of scale will give you the direction that you can select the processes by which you can produce more variety. You can produce more variants from the same processes. So friends, we have seen that process selection is very important aspect for an efficient organization, for a organization to produce product and services in an efficient manner, in an effective manner. The wrong choice of processes may lead to high cost of manufacturing, may make it inflexible in coming times when there is a change in the requirement of the product, there is change in the characteristics of the product. Your technologies, your processes may not be able to handle that. So in that way, we find that this decision of process selection is highly strategic, because any technology which you are purchasing, it is not easy to change the decision at a later stage, and it will affect a large, it has a long time horizon through which it has a long impact for a longer period. Any technology, any machine, if you have purchased, it is going to be with you for next 10 years, 20 years. So we should be very judicious in selecting our processes, selecting our technology. In continuation, we will talk about the capacity planning also, how much capacity I should keep in mind, and also we will talk about the aspects. These days we are talking about Industry 4.0, how the Industry 4.0 is influencing or will influence in the future our design of products and services. Because in the Industry 4.0 arena, we will find that all our products are smart products, possesses smart factory, produced in a smart factory. When we say smart, that means autonomous in nature. without human intervention, without the monitoring over the performance of the human being, the products will perform of its own, the processes will be carried out of its own. So, this was some of the ideas about designing the products, services, and selection of the processes. Thank you so much.